can assist you or tutor you more. If you have more questions, just email me. Here we go. The dynamic courses, the first video, and it's the first question of the chapter 12, the first question of the first section of chapter 12. So let's get started. It says the starting at rest, a particle moving in a straight line has an acceleration equals 2t minus 6 meters per second squared, where t is in seconds. What is the particle's velocity when t equals 6, and what is its position when t equals 11 seconds? So for dynamics questions, it's always the best when you can write the problem out in your own way. So I listed it out over here, right? Acceleration equals this function represented over here, and we know that dv dt gives us acceleration, right? It's the change in velocity per second, and velocity equals change in the distance, right, per second. So it's trying to find velocity at 6 seconds and distance traveled, or position to be exact, right, displacement position at 11 seconds. And this is the way of representing it, right? X is still the distance, and the dot on top, the one dot is taking the derivative over time per ones. So acceleration is twice, and obviously speed is, velocity is one time, right? It takes the derivative in terms of t once. So let's get started. So we're trying to take the derivative of A. Let's see, is it the right color? Right, here we go. So A is, we can write it as dv dt, right? A equals 2t minus 6. So when we're doing the operations, we can forget about the units for now, and verify it at the end, right? So times dt both sides, so dt times dt, right? And this thing, oops, yep, over here, and dv. Take the integral, right? dv 2t minus 6 times dt, right? Taking the integral, everything is good. So taking the integral of nothing in terms of v, so that would just give you v, because there's a 1 in front of it, right? And taking the integral of this equation in terms of dt, that would be t squared minus 6t, right? And now we plug in what? T is 6, so it's 36 minus 6 times 6. Ooh, look at that. Velocity equals 0 when times is 6 seconds, right? So equals to 0. That's a 0, not a 6. And now let's take the derivative, take the integral again. So we already calculated what v is, so now is a ds dt. That equals to v, right? Equals the equation we just calculated, 2t minus 6t. Taking the integral of dx, integral of t squared minus 6t dt, right? Bracket over here, and this is t to the power of 3, 1/3 of this, and minus, let's see, to the power of t, 2, 3, ta-ta, voila, right? Seconds. And now if you plug everything in, ooh, it's going to be 11. So it's going to be 1/3 times 11 to the power of 3 minus 3 times 11 to the power of 2 equals the position. In the end, you should get 80.666 is going forever, and which in the end simplifies. You can write 82/3 or 80.7. And don't forget the units, it's meters, just meters, not meter per second, right? So over here we say 80.7 meters, and here we say meters per second. And this is the procedures of solving question 1. It should be relatively easy. If you have problem solving this one, then I would be a little worried, right? What is exactly going on? Should be able to review your understanding on calculus, but don't worry. The calculus part, won't be so challenging that quickly. So do spend your time trying to catch on your knowledge on calculus, especially the physics part. But yeah, good luck on your studies, and I'll see you in my future videos. Bye. If you have more questions, specific questions you would like me to do, please comment in the comment section down below.